Hello and good afternoon from Antwerp.
Now we're live.
Hello and good afternoon from Andy Zeitman. I'm currently in Antwerp, Belgium. The weather is not so good, but I'm glad you're all here for the MSR award session. Normally, my partner in crime, Jenny Zhu, who was my co-chair for the MSR awards, would also be here, but she gave me the privilege of hosting today's session. Today, we're going to have two talks. The most influential paper award from MSR 2010, the MSR Foundational Contribution Award. And I also want to mention that we have an honorable mention for the most influential paper awards by Gregorio Robles and the Rick Holt Early Career Achievement Award, which was won by Alberto Bacchiani. Then, without further ado, the most influential paper talk by Michele Lanza, Marco D'Ambros, and Romain Rob for their paper, An Extensive Comparison of Bug Prediction Approaches. And what I've been told is they're going to present all three, so enjoy.
Okay, I'm about to start. Let me know if it's all good. So I'm sharing now. I assume if I don't hear anything, I assume it's working. So good afternoon. My name is Marco D'Ambros, and I am the director of Code Lounge, a research and development center at the Software Institute, Università della Svizzera Italiana. And I'm here with Professor Michele Lanza from the Revere Group, also at Software Institute, and Professor Romain Rob from Libera Università di Bolzano, Italy. And we're here to present our talk about the most influential paper award. What is this about? Essentially, the idea is that we are now in 2020 at MSR, and we look back at MSR 2010 to see like which paper presented back then had like the largest influence in the following 10 years. So this gave us the great opportunity to reflect about what happened back then and also what happened in these past 10 years. So back then we were all in Cape Town. It was a great conference, great place, we had a lot of fun. And now we are supposed to be in Seoul, great place, but because of the current situation, we are not there. And we are, as we hear all the time, working from home, at least most of us. So if you go on a stock photo website and search for working from home, you will find a picture like this. However, in many cases, at least in my case, the situation is more like this, working from home. So in terms of like our personal life in the past 10 years, we took like our picture from back then, and we were also like starting to learn parenting. And then if you look now, we are a bit older, much wiser. And of course, our family got a bit bigger, so we kept ourselves busy on that dimension. So great fun. And now let's actually move to the more technical part. So this is a trimmed version of the original presentation that I gave in Cape Town 10 years ago, which thanks to Michele is still around because mine got lost on a computer switch, I guess. So let's jump into it. So we are now in 2010, and we realized that in defect prediction, there was like a lot of research. Our survey revealed like more than 100 papers were published and more than 10 years of research. the techniques were using a number of different information, for example, information extracted from source code or from the versioning system, or historical data from the bug tracking system. However, all these techniques were not easy to compare, if not impossible to compare, because they were measured using different metrics, they were run at different granularity level, and they were also evaluated on different systems. So if you have to say which technique works best, you actually can't say, because you don't have the data to say that. So based on this observation, we had two goals with our paper. The first was to start and propose an initial version of a benchmark that can be later be extended for to have a baseline to compare prediction techniques, and then use this benchmark to compare existing approaches from the literature. And also, since we were at that, why not devising a couple of new techniques and then see how they perform with respect to existing ones. So we took representative approaches from the literature using a number of different information. As mentioned before, information extract from source code, like complexity metrics, information from versioning system and previous defects, and also like entropy of changes, which measure how complex changes are in terms of how distributed they are in the code base and in time. We also propose a couple of new techniques. I'm not going to go into the details for time reasons, but essentially they improve existing techniques by adding information about the source code complexity. And then most importantly, we took 5 considerably large Java software systems, all with a number of years of development. And then we took a number of snapshots, which means like checkout from the versioning system of the whole software. And we extracted all the versioning system data, the bug tracking information, and we aggregated this data and make it in a consumable format. So this took a considerable time to collect all the data, to process the data, to clean the data. And so once this was done, we thought, why not making this data public? So, you know, other people don't have to go through the same pain of doing all that we did. So we put up a website where we put instructions on how to use the data, and also we put the links to actually download the data. And it turns out the website is still alive, and looks like people are still looking at it 10 years later. So we then devised a scoring function to compare the approaches. Not important how the scoring function works now, but we use that function to compare the different techniques. And again, like it's not important the actual results, in my opinion, but I mean, some techniques work better, but they are computationally extensive. So it takes like quite a bit of effort to run them, and also they need a lot of data to run. Other techniques had like reasonable performance with like very cheap to run, and others were not good in the sense that they work well on some systems, they didn't work well on other systems, so they were not very stable. So we concluded saying that as of 10 years ago, it was very difficult to compare bug prediction approaches. So we created a benchmark, the initial version of a benchmark, make it available for other researchers, and we use it to compare approaches from the literature and a couple of techniques from ourselves. So let's jump back as of 2020, as of today. And now I would like to do a couple of reflections based on the paper and based on what happened in the past 10 years. So for me, it's important to see like the journey I went through in the past 10 years. I started from 2010 to 2012. I was a PhD first and then a postdoc in the Reveal group in Lugano. Then actually in 2012, I moved to the industry where I work for Palantir and I work on a very interesting problem. One example is the Formula One team at Ferrari. We work with them to create a data analysis platform for the telemetry data of the Formula One car used on the track. And then in 2018, I moved back to academia, joining as a director of Code Lounge, which is a new center for software research and development. So what is most important for me are the 6 years that I spent outside of academia, because I could have a different perspective of things that I couldn't see when I was inside. So the first observation is that during this time, when actually didn't pay attention on what was happening in academia, the number of citations for that paper, for the MSR 2010 paper, were like steadily increasing year over year, and including also the citation for a subsequent MSA extension. So every year, the paper was cited more than the previous year. In the meantime, what one would expect is, okay, so you work in research, you had all these techniques for bug prediction, then you move to industry, and of course, you apply these techniques to make your life and the life of your colleague better. And in fact, this didn't happen at all. So I never used bug prediction. I never saw anyone using bug prediction. And I never saw anyone with the need of bug prediction. So what does this mean? If we look at the citations of our paper, plus the citation of, or like the papers we collected for our literature review back then, so we're talking about more than 1,000 papers that are about bug prediction. So this is a very significant effort in terms of research. If you look at the industry impact, it is used in industry. So I know about, for example, Google use it, and Microsoft, also like Facebook as a technique, and Mozilla as well. The Mozilla one is also publicly available. However, the usage is still very limited, because it's used, first of all, by very big companies with considerably large code base, and also with a lot of history. And also they are like narrow in scope. So if you look, for example, at the Facebook one, the technique is mostly about null point exception problems that can also be solved with like language features, as for example in Kotlin. So I think there is a considerable gap between the effort in research and what is happening in industry. And I think that's something that should be addressed. Not that research should only serve industry, but at the same point, you have at one point, you need to close the loop and to make sure that the effort that you make on one end is eventually resulting on the other end. The second reflection also comes from the time I spent outside of academia, this time on a different dimension. So as all of you, like from 2010 to 2012, was going to conferences. So here is a list of the ones I attended. And then in 2012, I stopped doing that. So I didn't go to conferences. I never heard about conferences anymore until 2018, when I was back, for example, on a program committee. And then I could see like the differences in 6 years. So I just had 2 samples, one in 2012, one in 2018. So didn't know anything that happened in the meantime. And the 3 main changes that I noticed were, first, you can now publish negative results. Second, many conferences are now double-blinded. And third, there is this great thing called replication packages. So I was in this PC, and they got a replication package. And I have to say it was awesome to have the code and be able to run it easily, to get the data easily. And now with Dockers or like Jupyter Notebook, it's really, really comfortable and easy to do this. So based on this, I reflected and thought that if you would ask me 10 years ago, what are the main contributions of your paper? I would have said like that we created novel techniques for bug prediction and that we compare them with the literature, and in some cases they were better than the literature. If you ask me today, I would have a completely different answer. And I think the main contribution and the reason I think this paper got the MIP award is because of the dataset, because we made this effort to make the dataset public. The dataset was of high quality, so people use it a number of times. We were getting email about the dataset. And so that like was an important step into the direction of being able to replicate research results. And it's interesting to notice that the honorable mention of the MIP of the same year is highlighting like something very similar, but Roman will tell you more about this in a moment. And if you look like 10 years ago, we were getting emails about our data set, and this is still happening today. So the last email we got about the data set actually is from 3 weeks ago. So we're still getting this email. People are still using this data from 10 years ago. Maybe they should probably get something a bit more modern, but still, for me, this highlights that the main contribution was actually the data set. And the reflection for me is, it's awesome that we have replication packages. I think we should push this even like stronger and farther, because there is no reason not to publish the data and the code together with your research findings. I mean, unless there is like privacy reasons or, I don't know, the competitive advantages for companies. But otherwise, I think like really that should happen all the time. And with that, I'll leave the floor to Roman.
All right. So thank you for this award. So I think we're all honored to get it. I just want to briefly talk about two things. So the first is this paper's place in the general trend of data sharing and replication, as Marco started to talk about. So clearly the key factor in the impact of this paper is the data set that Marco provided, but we were neither the first nor the last to provide such a data set. So when we published this paper in 2010, so well, the promised data repository was already existing for several years. Software engineering artifact tracks would come soon. And in MSR itself, there was an MSR challenge with shared dataset running for several years already, and there would soon be an MSR data showcase track. And in this broader context, as Marco also pointed out, I found it especially fitting that Gregorio's paper is recognized. So Gregorio spent a lot of work like combing through the MSR proceedings and pointing out that the community was not doing a good job in sharing data and tools. And I think this paper had a major impact going forward, for instance, in the establishment of the dataset track. So there are lots of other datasets. So I think what made this particular dataset influential really is the time that Marco spent to make a very, very nice dataset and associated website. I think that's what made this dataset stand out from the others. On the other hand, that's kind of the second thing I want to talk about, that I sometimes wonder if it was the wrong dataset. As Marco mentioned, he did not use bug prediction in the industry. So we actually know of a couple of examples, and those examples had, let's say, mixed results. So bug prediction was deployed at Google, integrating the code review process, and developer found that the warnings highlighted there were not really actionable, so they could not really exploit them. At RIM, the experience was more successful, but there are two key differences. The first being that it was more about prediction to level of changes, which is a final level of granularity, but with a whole set of different challenges. And the second is that it was encompassing risk, which is a broader classes of changes than simply bugs. And in both cases, it was related to code review. And we know from Alberto's studies, for which he's actually awarded this year, that reviews are about way more than just defects. So to sum up from my side, so while our dataset attracted significant interest, I cannot but wonder whether the task that we looked at is slightly wrong. So in the years going ahead, I am looking forward to, well, what the next benchmark will be. And with that, I hand it to Michele that has a bit more to say about benchmarks.
Yeah. So wait, share this, share that. I I hope you can see this stuff. Okay, I will be quick because time is running up. I would just like to complete this whole thing with the remark that I was also a keynote speaker at MSR 2010. It was my first keynote. I only had 187 slides. Later on, I progressed on that. It was called the Visual Terminator. And during the keynote, I made a couple of predictions and expressed some wishes. The first one was that MSR as a conference resembled a candy store, that people could mine whatever they wanted. And back then it was a rather lonely affair. We were not a lot of people doing that, but I predicted in that keynote that the floor would fill up. And I guess I was right considering the 320 plus people registered this year. And I also predicted that, or I wished for one thing, and that is when it comes to the work that the MSR community does, that it would all be about quality when it comes to data. And that eventually this would lead to something that I called back then benchmark glasnost. So high quality benchmarks, well documented. And this, in a way, I think is what really made the paper get the MIP in the end. So that's it. Thanks for the award.
And congratulations again on the MIP award. Let's go over to the questions. And I see there are 2 questions right now in the Slack. And Sarah Nadi is asking, reflecting back, what was the format you shared the dataset in the best format? Would you change this now? And how did you manage to support this dataset all these years? Students graduate and move on, so it becomes challenging. And especially because Marco was saying that even now you're still getting requests for that dataset. So any comments there?
Yeah, so the first, so about the format, I think the format doesn't really matter as long as it's like an open format that can be consumed. So I mean, CSV or JSON, it doesn't really matter. I think it's now the number of tools that are available to process and consume data is so wide that it doesn't really matter. When it's about scale, then it's a different story, but that data set is not doesn't pose challenging problems. I think now it would be interesting to go with approaches that maybe, I don't know, like a data set on the cloud where you can run some computation would be interesting. But then the question is who's going to pay for that computation? So I think if we don't have scale problems, any format works. Second question is interesting because we didn't do anything. We just put the data on the website. I actually was surprised myself that the website is still there. So if you have an IT service in your university and the data is stored on a file system and people don't do delete stuff just for the sake of it, it's just going to work because it doesn't need data doesn't need maintenance. It's not code that is evolving.
Marco, you're wrong about that, huh? Because during all these years, I got several requests from IT to shut down the website, and I told them to buzz off first. Second, I should mention that when you went away from here and Romain went away to Chile, your email accounts were deactivated. Now, guess who received all those emails during all those years?
Okay, so the magic is to have a friendly supervisor who responds to his emails. We'll take you on that, Michele.
And unfriendly to the IT services.
Okay. Good advice. Thank you. One final question here from Neil. On the one hand, building the dataset is non-trivial and clearly highly important for the research. However, I doubt anyone on the team started a project with the goal of building a dataset, and you don't get PhDs for building datasets. What does this imply for the community and for the research goal itself?
Who's going to take this one? Well, I guess I'll take a stab. So I think for us, the experience was that we had to do the data set because we needed to for the research. So the initial goal was to do a benchmark and to create techniques that were actually better than the literature. But then once we had it, the extra mile to make it available was actually not that much. So it was just like putting it on a website. So I think if, I mean, you don't do it for the sake of it, you do because you need it to run some techniques on it. But once you have it, I don't see why not sharing it.
I guess a quick follow-up would be, yeah, I don't know whether you should not get a PhD for a data set, but one thing that changed right now is that at least you can get a couple of publications now, thanks to the data showcase track, and you can, even with MSA, you can even like get a journal paper about your data set. So I guess that cannot be like the be-all and end-all of your PhD, but it can still be something for it.
Which means there's the risk that the means becomes the end, of course, that people just start mass producing data sets for the sake of cheap ass publications. So there's a risk. I think back then, basically, it was a genuine thought of Marco, most of all, who has always been a very energetic PhD student. And he just said, like, and also very open-minded, like, why don't we put it out there? And it's cool that he did. He got us an award and the trip to Korea. Yeah.
Absolutely. Thank you all for the nice presentation and the Q&A, and congratulations again. That being said, our second talk of the session is the MSR Foundational Contribution Award. The recipients are Jonathan Malatic and Michael Collard, and they get the awards for the incredible SourceML infrastructure, which addresses so many problems and which our community has used at so many occasions. So I'm not sure who's gonna start the talk, but up next are Jonathan and Michael.
Okay, let me get my screen shared. Okay, and okay, so everybody see that and everything? Thanks a lot for this award. It's meaningful to us. We've spent a lot of time working on SourceML. So first, we're going to give an overview of what SourceML is, and then we're going to talk about some other implications. SourceML is basically this infrastructure to do an exploration, analysis, and manipulation of source code. It's also the XML format, so there's a SourceML format. And there's lightweight parsing technology behind it that's very scalable and robust, and it does multi-language. And this tool is open sourced under GPL. It really is an infrastructure. So at the bottom, there's the SourceML format. And then above that is this parsing technology. And this works in XML, produces an XML format, so we can use XML tools and build additional models. And then on top of that, we have tools to do general software engineering tasks, things like transformation, refactoring, slicing, and exploration. Mike is going to come in here and talk about SourceML in a little bit more details.
Okay, so I hope you can all hear me. So what does SourceML do? Well, you can convert source code to SourceML, and you can take the SourceML and convert it back to the original source with absolutely no loss of the text. When it's in the SourceML format, you can query the code using XML query languages such as XPath, and you can transform the source code in the SourceML format. And the workflow here is convert from source to SourceML, apply your transformation, and then convert from SourceML back to source. So the SourceML format is a document-oriented XML format where we take the structural information and we insert it directly into the source text. And our markup is kind of selective. We try to keep at a high AST level. So classes, functions, methods, statements, declarations, expressions, and then names and operators. So here's a simple source code file, kind of the de-rigor source code example. And next we have the SourceML format of that single file. So in SourceML, the SourceML markup, all the original text is preserved. This includes white space comments and special characters. What we do is we take the syntactic structure of the code and we wrap it with tags, which allows us to address this in XML applications. The comments are marked in place and the preprocessor start statements are marked in place. And a note here is we do not run the preprocessor before we convert to the SourceML format. So we implemented this in C++ using the Antler parsing technology and a couple of other libraries, libxml2, libarchive. Our current speed to convert from source code to SourceML is almost 100 kloc a second. And this is kind of important in an XML format. Our size of SourceML compared to the text is about 4 to 5 times an increase, which is pretty reasonable. If you compare a compressed SourceML file to the compressed original source, it's about 1.5 times. And we allow for a wide variety of input sources, including, as we saw, single files, directory trees, source archives, zip files, and so on. We have our own custom parser. It's based on the Antler parser framework, which we have heavily modified. One thing we did to handle comments and white space is put them in a separate token stream. And also any C preprocessor statements are in a separate token stream. And so the parser really produces a token stream with the XML tags inserted. And this stream approach makes it really highly efficient and scalable. Currently, we support C, C++, Java, and C#. We are also able to mark up Qt extensions and OpenMP pragmas and even handle KNRC. So our last release is SourceML 1.0, and the primary reason for this is to freeze and version the SourceML tags so people could write applications against a fixed tag set. This includes our SourceML client program and our libSourceML C API. Now, SourceML can represent, as we've shown a few slides ago, a single file. We're talking here about the parser and the format. It can also handle code fragments down to the statement or expression level, and also scales up to complete projects. And when you scale up to a complete project, our SourceML client supports multi-threaded translation. So in a couple of minutes, you can convert a very, very large project to the SourceML format. So we have a variety of ways of using SourceML. You can use the SourceML client directly, give it some XPath and throw it at some source code. This is a very quick way of getting a result or to check what your XPath is. You can use the SourceML client to generate an XML file in the SourceML format, and then you can apply various XML tools to that. You can also write your own application code that uses some sort of XML parsing library. And then another option that we have is the SourceX framework, which allows you to very efficiently collect information from a large code base. Thirdly, if you want to bypass the client, you can write your own application code and directly use our libSourceML library.
Okay, we put a lot of work into this and it didn't happen overnight. Basically, we've been working on it for about 20 years. So back when I was at the University of Memphis, I had a good idea. And then I moved to Kent State and came up with a prototype. Mike started working with me about that time and he came up with a better prototype and we got a couple of publications out of this. And then people started using it around 2004. Guys like Giulio Antonio and Paolo Tonella started using it and giving us feedback. And around that time, I met Brian Robinson at ABB, and he actually gave us some funding, and this actually helped out quite a bit in moving it forward. And we got people from industry using it. In 2013, we got some NSF funding, a substantial amount, and that really moved this from sort of a research prototype that people could use to a tool that was really industrial strength and really robust. We started using, because it was a real piece of software, we started having to use real tools like Docker and GitHub and things like that. We came up with a lot better documentation. And like Mike said, we have a new release in 2020 of 0.1. or 1.0. There's also been approximately, since we've been taking counts, we've had about 7,000 downloads since 2015. We've used SourceML for a lot of things. People have used it for slicing, pointer analysis, computing metrics, refactoring, syntactic differencing. We've used it for reverse engineering UML class diagrams, a whole slew of things. This is a small number of people who have used it from outside of our group, and they've used it for a lot of different things. And a lot of these people have given us some nice feedback. We also have built tools on top of SourceML, and some of these are available. Our SourceSax is a nice interface to help people use it and reduce barriers of adoption. We have a slicing tool that's highly scalable, lightweight pointer analysis tool, a typing, something to generate UML class diagrams, and a stereotype tool. We have some tools that aren't released. SourceDiff is really close to being released. This is a really nice, fairly scalable syntactic differencing tool, which has some nice output. We have a recent paper on that. We have a nice query language, but this is hard. This is when you get students come and go. And this is one that's kind of sitting on the back burner, which could be very useful, but hard to get moving forward. We have a transformation language also, and a couple other things that are working on. Here's some of the big contributors in the team over the years. Brian Bartman, Michael Decker, Drew Ganera, Heather Ganera, Christian Newman, Mike Wine, and Voss. They've all made some big, substantial contributions over the years, and it's nice to have them around. So what's going on for the future? We had some NSF funding. It's ran out, but we are continuing to do maintenance and releases. So you can look forward to having some stable releases in the future. We wanted, what people are asking for mostly is more language support, domain specific languages, things like Swift and Python. We did submit, Mike and I submitted a proposal in January to the National Science Foundation to develop a parser generator so that you give it like an ANTLR type grammar, and this will generate a parser to SourceML. We have recently heard that that is recommended for funding, so we can look forward to that coming down the pipes. So that kind of concludes our talk. Here's the webpage, sourceml.org. Thanks, and let me know if you have any questions.
Thank you, Jonathan. Thank you, Michael. Extremely important work and used by so many other people. I think you fully deserve the foundational award here. I don't see any immediate questions, but my question would be, 20 years of development, I mean, how did you motivate students to keep working on this? And how did you motivate yourself to keep working on this?
Mike, when Mike graduated, he got a position close by, a couple different positions close by, and we just continued that collaboration over the years. And he's been a real driving force behind making this work. It's his baby, the code base. So I think it's his hobby.
It is my hobby. I also want to point out that many of those people on the contributors list started working on these as undergraduates, both with me and with Jonathan. So they were able to be around for a much longer time than your typical, let's say, grad student.
Yeah.
Like, for example, Decker has been working on, was involved with it back as an undergraduate.
So was Christian and Brian.
Right.
And we were lucky to get, all these guys are excellent developers, and not all grad students are excellent developers. So this was, some luck there.
Okay. Michele also has a question. What importance does dog feeding play in the development of SourceML as opposed to getting requests from external people?
I'm sorry, I didn't hear the first.
So what importance does dog feeding play in the development of SourceML as opposed to getting requests from external people? So how much does your own needs drive the implementation?
You know, a number of people have given us some really good feedback and, you know, asked for things. So the industry folks have gone, hey, look, we would like this. You know, Julio and Paolo actually said, hey, I would really like this or that. Paolo actually pushed us to do Java early on. So yeah, we really did listen to our user base quite a bit.
All right. Thank you very much. This brings us to the end of this session. Congratulations again on all the winners, also the ones that were not having a talk today. And I think it's back to Sarah, Georges, and Sung for the closing session.
Okay, great. So we want to thank you all for joining us across all different parts of the world and then time zones. And we also want to thank all the MSR 2020 organizing team really behind the scenes, including our social media chairs, web chair, publicity chair, and presenting chair, and all track chairs. Thank you so much. And then I especially want to thank to our two PC chairs for their tremendous commitment. You know, just a lot of work, especially this year. But I think they handled it very, very well. Basically, we are so lucky to have our amazing two PC chairs. Thank you very much. And this is not really a closing, since we still have sessions going on after this. But this is actually the best time spot to across time zone, so that we just want to tune in and then thank you all while we have you all here.
Great. Yeah, so this has been a new experience for all of us. So some things worked well in a virtual setup, some things didn't work as well. But of course, since we're here, we're going to tell you about all the awesome things that worked. So honestly, this new format has some advantages. So for example, in our Slack workspace, so far we have 285 participants, more than 1,300 messages. And one of the very nice things we have this year is the intros channel. And right now we have introductions from more than 100 participants. So this is a great resource you usually don't have in a physical conference. So you can kind of go back, check all the intros, reconnect with people. We will keep this workspace going for as long as people are in there. So you can kind of go back and check things. We also had a mentoring channel. If you haven't checked it out yet, go check it out. There's great advice for conducting user studies and different kind of studies. So yeah, so there's good things here, maybe things we keep for a physical conference even.
Well, what you definitely don't have in a physical conference is a YouTube channel. We made significant use of Zoom and YouTube for this conference. So far, our videos on YouTube have more than 7,000 views, which is around 500 hours of watch time, just in 1.5 days, and we're not done yet. The good thing basically about having YouTube is that those videos are going to be available for after the end of the conference. Personally, I believe this is one of the most important benefits of running a conference online, that this material is going to be available and it can be used, for example, in classrooms or in other events where perhaps the speaker cannot attend and so on. We also had quite a few live sessions. And on the technical side, though, this has been relatively okay to set up. And, you know, we had quite a few, quite a big attendance as well. For example, the session yesterday for software engineering for machine learning has been viewed 1,000 times already, which is great. It's going to be available further on. We still have one more live session after we finish that one. And we hope that you all be joining for the machine learning for software engineering live session later on.
Great. The conference is still going on, so definitely we encourage you to join the remaining sessions and interact with other people on the Slack, and then share your ideas, maybe find like a best paper ideas for the next MSR and so on. And then while we are enjoying MSR 2020, we want to take this opportunity to invite the MSR 2021 chairs to let you know a little bit more about the next year. So I'd like to invite all MSR 2021 chairs to the microphones.
Okay, so good afternoon in Europe, good morning in the Americas, good evening in Asia, and we have even some people from Australia and New Zealand where it's already night. So my name is Gregorio Robles, and I will be the general chair of next year's ICSM MSR, sorry. And let me see, I want to share my screen. So I hope to share the screen. No, it's not in here. I want to present. So we have a small presentation about next year's MSR 2021. So next year it's going to be in Madrid. The dates are May 23rd and 24th. That's a Sunday and a Monday. And as always, it's being co-located with ICSI next year. Next year, ICSI is going to be Tuesday to Thursday if everything goes well. So here's the team. So I already presented myself. And then we have got Kelly and May as program co-chairs. They are here in the room for you as well. So they will present a little bit on the program in a couple of minutes. So most of you probably know where Madrid is here, just so that you remember where it is. It is in the middle of the Iberian Peninsula, southern part of Europe. Most importantly, if you look at the city map of Madrid, I don't think you see my pointer, but this is the city center of Madrid. You see on the right-hand side, the airport is not very far away. That's 12 kilometers from the city center, like 8 miles. The venue is not going to be in the historic city center, which is, if you look here at the green spot, which is the Retiro Park, that's like the central park of Madrid. That's the historic city center. We're going to be farther north, a little bit farther north, close to the Real Madrid Stadium. That's the financial district of Madrid. It's very easy to get there from the airport. There's a metro line going there directly from the airport, and there is where ICSI is gonna be and where we are gonna be next year. As I say,
sorry, Gregorio, to interrupt. We can't see your slides.
Oh, sorry. So I'm sharing screen. Let me see. Desktop one. So let me know if you see now my slides.
Yes, I can see them on my side.
So then I will just go to, so that you see the pictures. So that's myself and Kelly and May, nice pictures. I just showed the map of Europe where Madrid is. Here's the city map. Again, if you see the green spot there, that's the Madrid central part, that's in the historical part. We are going to be 2.5 kilometers farther north in the financial district. That's where ICSI is gonna be next year in a big hotel. And we're gonna be there as well. As I told, if you see the airport is on your right, that's not very far away. You can go there with the underground very, very easily. And then regarding the weather, it's late spring in Madrid, and that's fantastic news. That's probably the best time to be there. It's not gonna be too hot. It's not gonna be too cold. And I see the average precipitation days is 7, well, which is the maximum in Madrid. Let's hope we have nice weather and we can enjoy the social activities that we are planning for next year. And that's on my side. I will leave the microphone to May and Kelly, who will be the program co-chairs next year.
Thanks, Gregorio. So we're still hoping that we will be able to be in Madrid, although our decision will largely depend on what ICSI decides for 2021. But we're thinking that it's likely to be a hybrid format. And that means that we will have some location in Madrid and that we will continue with that, but we will also be enabling virtual participation for those that don't want to or cannot travel due to their situation. We're going to have the same tracks as MSR 2021. So the main technical track with regular and short papers, the data showcase, the mining challenge, and we will be putting a call out for proposals for that challenge soon. And also an education and registered reports track. So we plan to keep the tracks that we did have in 2020. And the dates for submissions will be very similar to MSR 2020 as well. So most submissions will be in January and February, and we'll be announcing all of that very shortly as we get the website up to date and the call for papers out. And we'll also be putting together our organizing team over the next couple of months.
And one thing new that we're going to add is we're looking to create something called a shadow PC, which we hope to have with students and postdocs and people who have not been an MSR PC member before. So what we hope is that they will review papers in parallel and receive some feedback on their reviews. We want to be able to teach the next generation of MSR participants what a good MSR paper is, how to review the papers so that we can have future MSR PC members who are just as good. We're looking to see how to work out the details, whether they'll be in the same installation of HotCRP or in a different one, but we'll soon have details on that too. So that is the one new thing that we are going to add for MSR 2021. So yeah, see you at MSR 2021.
Yeah,
thank you. Yeah, and thank you to Sung, Sarah, and Georgios for giving us this opportunity to advertise MSR 2021.
Sure.
All right, great. So yeah, so thanks to the MSR 2021 chairs, we really hope it will be a physical conference and we get to see everybody, but we also look forward to a hybrid approach, kind of maybe leveraging some of the things we learned this year, especially Georgia's clicking go live and praying that things will go live. So, okay, so just coming up, we have 3 more technical sessions. We have one Ask Me Anything session on machine learning for software engineering and one tutorial. So make sure to tune in, go to these sessions and make use of Slack and the rest of our program. All right, yeah. That's it from our side.
Yeah, let's enjoy the rest of the MSR 2020 and see you all around.